Hey, it's Jillian, and we're going to take a look at factoring special quadratics. So previously we had multiplied out special binomials or perfect square trinomials, and now we're going to have the answer, and again we're going to factor to get the question of multiplying out. So here we go. When we have something, there's two special there's two special quadratics. First, we're going to do a difference of squares. As you can see, a difference of two squares. When you have a difference of two squares, you will factor, and it will be the square root of the first at the beginning of each bracket, the square root of the last at the end of each bracket, and the signs will be different when that's a negative. When that's a positive, it's not a difference of squares, it's a sum of squares, and none of this applies. So let's take a look here. If this is the case, I'm going to say, okay, I've got two brackets. The square root of x squared is x, because x times x is x squared. The square root of y is y, and then the signs are different. That's it. Here, I'm going to write this like this, so it's something squared minus something squared. You know 3 squared is 9. And then I'll write it up so that we have that goes here, that goes here, and then the signs are different. Let's see here. So here, what am I going to put in this bracket? 4x squared is all 2x all squared. So that just means 2x minus y, 2x plus y. Pretty simple, huh? All right, let's keep going. Here, what squared minus what squared do we have? Here we have 3x all squared, and this is 11y. So we've got 3x minus 11y and 3x plus 11y. Here, well, it looks like we have something to common factor out. And certainly I know 80 is not a perfect square the way 121 is, or 9, or 4, or any of these other numbers. So let's take a look. What can we common factor out? Well, something that ends in 0 and 5, we know we can for sure common factor out of 5. So let's see what happens. 5 goes into 80 16 times, and 5 goes into 45 9 times. Well, now you can see we have perfect squares. So what will we do? This is 4a all squared, and this is 3b all squared. Let's take a look at this one. Here we have a binomial square, and then there's that. So now what I'm going to do is I'm going to write 4 at the end, plus and minus, and then x plus 3, x plus 3, because that's the first perfect square. Now I have some things to simplify in here, so I'll just do that. Okay, let's keep going. Here, what do we have to common factor out? We don't have a number this time, but we do have a variable. So let's do that. And then we have 10 times 10 is 100, as you know, minus plus, and 9x all squared is 81 squared. Done. Here, let's put this in something squared minus something squared form, so we see what goes in our brackets. And what do we have? We have a 2 at the beginning, and at the middle are different signs, and then we have an x minus 1 here and an x minus 1 here. Now it's really important you put these brackets in the brackets, because negative, because this is not the same as this, right? That makes this negative and this positive. And if you don't have the brackets there, you won't make that positive. So it's important that you put those brackets in. And then you simplify. 2 minus x plus 1 and 2 plus x minus 1. And then we have 2 plus 1 is 3 minus x. And 2 minus 1 is 1 plus x. All right, let's keep going. Let's put this in a perfect square minus a perfect square. So that is x over 4, and that is y over 5. So when we do our brackets, we'll have x minus 4 minus y over 5, and x over 4 plus y over 5. Okay. How about here? Okay, well, what x to the power of 4 is what squared? It's x squared squared. We're used to seeing x squared squared and making it x to the 4, but we can break it down like that. And then, of course, we know 16 is 4 squared. So then we have x squared minus 4 and x squared plus 4. But here's the thing, you have to look. This is another difference of squares, which we can continue to factor. So that'll be x minus 2, x plus 2. And then this is not a difference of squares, so we just copy it down. There's nothing more to do with that. Then let's take a look at this one. Here we have something squared minus something squared. So we have, I better use square brackets for this one. So we have x minus 3 minus x plus 3. And then we have x minus 3 plus x plus 3. Right? First minus the second, first plus the second. So now let's simplify. We have x minus 3 minus x minus 3 and x minus 3 plus x plus 3. So here the x's are gone and we have negative 6. And here we have 2x, and the 3's are gone. So negative 6 plus times 2x is negative 12x. Wow, all of that ended up just being that little term. How about that? All right, let's take a look at the rest of our special quadratics. So now we just finished difference of squares, and we're going to take a look at perfect square trinomials.